All right, so this is the review. All right, this part is a no calculator. This part is no calculator. Do this right now. Write that with no calculator help whatsoever in scientific notation. Write that with no help whatsoever in scientific notation. If you can, say, I can. If you need a little help, say, ooh, I need help. Okay, those of you at home, people were talking, you just couldn't hear that. All right. What we do is we put the decimal where it currently is, and we put it somewhere to make the number between 1 and 10. 7.9 is between 1 and 10. And then we count spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's time 10s to the 9th. If you were writing this down on paper, you could write 7.9 E9 if you want to do. That's the way the calculator would make it look. All right, would you please write this one with no calculator in scientific notation? 0. If you're far enough back, there are 4 zeros to the start. So with no calculator, please write that one in scientific notation. Just a slight tricky trick. You're either going to put the decimal right here or you're going to put it right here. You either put it between the 4 and the 0 or the 1 and the 7. Why do you put it between the 4 and the 0? Makes the number between 1 and 10. So don't get confused. The number, the new decimal is going to go right here. So it becomes 4.017 times 10 to the way I taught this to you, if it's a small number, make it a negative. Some teachers teach left, right. I don't think you need to teach. Just small numbers are negative. You're counting spaces. 1, 2, 3, 4, 5 times 10 to the negative 5. How many have got 2 out of 2 correct? Heck yeah, good deal. All right, with calculator, and you got to ask me like now or before the test on how to use the calculator. Let us do this, please. 6. And answer, please, in scientific notation. Answer in scientific notation. That's what my calculator said. Did your calculator say that? Yeah. Answer in scientific notation. The real decimal is here. You want it here. 1, 2, 3. It's a big number. Say yep. Cool, cool, cool. All right. Using your calculator. That's the scientific notation times. That's the times. anyone need help using their calculator? All right. No calculator, no calculator, no calculator. Answer in scientific notation. Answer in scientific notation, no calculator. Well, 3 times 4 is 12. When multiplying with the common base, you add the exponents, add the 8 and the 7, and it becomes 10 to the 15th. Please do not walk away. Please do not walk away because you're not in scientific notation. This 12 has to be made into scientific notation, and it becomes 1.2 times 10 to the first. Move it once. Times 10 to the 15th. Now the final step, adding that 1 and the 15, and it's 1.2 times 10 to the 16th. I am sensing that when I end up grading this part of the test, that pretty much I'm not going to mark many wrong. Am I correct? I won't be marking many wrong. I'm correct on that? Good, good, good. That was a pretty basic part of where we were at. All right, now comes the exponent fun. And people might have different ideas of the exponents being fun. We answer with no negative exponents, no negative exponents, no negative exponents. And let's practice one like this. Exponent to an exponent, we multiply. X to the negative 40 and y to the 50. Just multiply my exponents. It's a rule we'll want to remember. Then the answer is not acceptable with a negative exponent. So if we remember, these are all over a 1 that we usually don't write down. And x to the negative 40 has a negative attitude. If it goes to the positive, it becomes x to the 40, positive 40. These are on top, y to the 50 is happy where it is. It's y to the 50. It stays there, and that's how we would answer that. Great, great, great. All right. Let's look like this here. Let's look with all of the people out in the hallway, all of the people out in the hallway, all of the people out in the hallway. Don't get squared. The 6 doesn't get squared. Don't take 3 times 2. That's 3 squared. That's 3 squared. Exponents, you multiply exponent to exponent. Multiply exponent to exponent. This is regular 6 times regular 9. It's regular 54. It's on top. It's 54 over 1. These all are over a not shown positive 1. X to the negative 10 goes to the bottom. Y to the 20 stays on top. Let me see something. All right, I can do a little more before I stop this recording. Then I got a really fun idea. You two in back. See, I don't want to record kids, But you two in back, I'm gonna have you cover your faces up, and then I'm gonna record that so the kids that are gone see what they're missing, okay? All right? Try not to look in the back corner or you might get, well, look at that. Whoa, whoa. Is that like, that's why people are showing up. Let's get a little ickier. I just put a -8 out front. These folks are just patiently waiting. And now exponent to exponent, exponent to exponent. I'm going to make a suggestion. Before we move anything up and down, we combine whatever we can combine. Folks, I can't stress this enough. This -8 is not an exponent, it's a -8. It's currently on top of an unshown one of a denominator. It's not going anywhere. That's not an exponent, that's a -8. I'm now going to combine my x's. I'm going to combine my y's. These are all over an unshown one. Repeating again. This is not an exponent, that's a -8. It stays -8. X -14, y to the 33rd. Okay. So I don't record students. However, both of you hold your notebooks in front of your faces. Okay. Look at that. Look at that area. Wow. That's what, anyone get tired, just go and look there.